I just want to say thanks. It's a great honour to be invited here, and I'd like to just say congratulations to the Alchemist Cafe team for putting together a really fantastic set of events. I went to my first recently, and I thought it was a great venue. I hope you still think so after tonight. So I'm going to talk about three things tonight. I'll give you the three titles of my 3 10-minute pitches to you. The first one is entitled Genetic Pessimism. The second one is entitled 10,000 Hours. And the third one is entitled Brain Capacity. So I'm going to start off the first one, Genetic Pessimism, with a question to you all, which you don't have to answer, but if you could, I'd be glad. So, how many of you would answer yes to the following question? You have a certain amount of intelligence and you can't really do much to change it. Who would say yes to that? Don't believe you. Yes, thank you. Thank you, somewhere. Okay. So most of you, okay, that's very interesting. That would be a very different response. Maybe, I suspect you get a different response in some parts of the world. So that's a very optimistic statement. I wish I thought there's a few more questions in this questionnaire. I only wrote down one of them, but never mind. Never mind. So most of you then don't believe it is the case that you have a certain amount of intelligence and you can't really do much to change it. Now, the reason I'm disappointed, so a small number of brave people at the back there agreed with that question, but that would be a very strongly prevailing belief certainly in a large number of circles in psychology, academic psychology, and it has been quite a strongly prevalent belief among a good number of policymakers in various countries over the years. So what I want to argue in the first part of my talk tonight is that pessimistic beliefs about the biological determinants of our capacities, our emotions, and our behaviors can be self-fulfilling prophecies. And I want to just give you a few examples of evidence that this is the case. So there's a researcher in Stanford University, Carol Dweck, who has developed a very interesting approach to beliefs such as that. And she studies children and asks them questions like that about the extent to what they attribute their capacities, usually their intellectual capacities. And she can grade children and adults as well on a scale of the extent to which they believe whatever the capacity they're talking about is, if you like, preordained by their genes or their biology or whatever, versus those who believe it's more malleable. And she just recently published a paper with Lisa Blackwell from Columbia University, where they measured such beliefs, if you like, fatalistic beliefs, if you like, about intellectual ability in a group of 7th grade children in the States. That would be children just about 13 going into first year of secondary school. And then she followed them up over 4 years, and she found that irrespective of actual ability, the ones who did not subscribe to fatalistic, pessimistic beliefs showed a steady increment in their mathematical ability over the 4 years, while those who subscribed to the, if you like, the pessimistic, predetermined view of their abilities, they showed level peg, they didn't show improvement. So that's the first piece of evidence I'd like to give you about our beliefs about our capacities fulfilling themselves. So the second one is various research on people at all ages. You can measure something called locus of control in psychology. That is, you can quite reliably measure the extent to which people feel in control over their lives versus the extent to which they feel that their lives are under the control over external factors that they don't have any control over. And across all ages, not just older people, across all ages, Windsor and colleagues found that people who believe they're in control of their own lives show higher cognitive function, higher mental abilities than those who feel less in control. And in a recent study, Jane Wardle, a former colleague of mine in London, study of several thousand people in Central East Europe, where there tend to be quite high levels of feelings of loss of control and low life satisfaction since the fall of the collapse of the Cold War. She found, and her colleagues found, that depression and low life satisfaction were associated with low perceived control and with the beliefs that of the influence of chance, of fate, over health. Okay, and finally, there was an 18-year study of people in their early 60s, and they followed them up over 18 years, large number, about 700 of them, and they found that those who felt in control and had positive attitudes towards aging showed much better health 18 years later than those who felt, if you like, the victims of circumstance and chance and biology. So my argument tonight is that our own theories about what determines our mental functions, but perhaps not only our mental functions, perhaps our emotional functions as well, our own theories about that actually shape how well these functions will emerge. Now, I'm going to focus tonight on cognitive and intellectual functions. But I want to make one thing clear. I'm not saying that there are no genetic or biological influences on our behavior. Clearly there are. And there are limits to all of this. You cannot stop or prevent Alzheimer's disease. You cannot override disability, intellectual disability that you've had since birth. But there is a very big leeway to play with when it comes to cognitive functions, and that leeway is affected by your own beliefs about whether there is leeway or not. So let me just elaborate on that a little bit. And we now know there's far fewer genes in the human genome than we previously thought. I say we, I'm not a geneticist, but there's 30,000 genes in the human genome approximately. That is not nearly enough to code for all the different varieties of behavior, the emotions, the thoughts, the different varieties of human behavior. The Nobel Prize winner Gerald Edelman has concluded and shown reasonably convincingly that every single human brain is totally unique. And it's totally unique because of its complexity and its interactions with many different environments. There are as many different brains as there are different environments combining with different genomes. So almost all our genes that are important for our behavior have evolved to interact with the environment. And the expression of these genes, that is, whether they get switched on or off, and by switching on or off a gene, you allow it to express the protein or not. The expression of proteins, the switching on and off of genes is hugely and vast numbers of genes affected by environment. So, and also environments interact with genes and amplify genetic differences, which may be highly heritable. So for instance, you may have a girl at school who has a genetically acquired athletic propensity that a gym teacher sees, but that may be a small difference from other girls in their class. It may be highly heritable, but what will often happen is you will then get that girl taken away for special training and special courses, and so you will get the amplification by environment of a small, highly heritable genetic difference. And this goes both ways. You can get the exacerbation of small genetic, highly heritable differences leading to deficits in behavior that result in a reverse amplification by the nature of the environments that then select for these small differences. So the old notion of nature or nurture is just gone by the wayside. We have the most complex intertwining of genes and environment has a huge effect. If I can just say one more thing in this section before I finish. The estimations of heritability of intelligence range from 50% up to, in some cases, 90%. And that is based a lot on twin studies. But what that doesn't recognize is that the heritability, that is how much something is genetically determined, your statistical estimate of that depends on how varied the environment you are in is. If you have a highly homogeneous environment, so supposing you go to Denmark, which is a highly homogeneous environment in terms of relatively low social and economic inequalities, the genetic inheritance, and many of the gene studies have been done in Denmark because of their twin register, the genetic loading there is very, very high. There was a recent study about 3 or 4 years ago published in Psychological Science of children from very poor areas of the United States, where there was a whole much greater variety in environments. Some kids in really dire environments, some kids in not bad environments. And they found in that particular population zero heritability for intelligence. And that was because, not that there's no heritability of intelligence, but that the environmental differences there were so large that they statistically swamped the genetic effects in the same way in Denmark, your estimate of genetic heritability swamped the small environmental differences. So let me end my campaign against naive and inaccurate genetic pessimism by taking the most extreme case. And I had a recent discussion with a psychiatry colleague about this, and he said, what are you saying about Huntington's disease? Take Huntington's disease. And I said, I'm glad you said that. Now, first of all, if there's anyone that had Huntington's disease, it is, for all intents and purposes, tragically not treatable. Nevertheless, Colin Blakemore, the famous Oxford scientist, several years ago, did a study with baby mice who had the Huntington gene. We now know the gene that it's a single gene disorder. And he took 30 of these Huntington mice, and he put one half of them in a normal mouse environment, and one half of them in a kind of super fun, stimulating mouse environment. And he followed them up over the next 100 days, and he found that the normal environment mice had a steady progression, conversion to Huntington's disease, started showing the symptoms of it. The mice in the unstimulating environment, only one of them, at the end of that period, was showing the symptoms. Now, the genes themselves had not been affected, but the expression of the genes, the degree to which they expressed the proteins that caused the disorders, was influenced by the environment. Okay, that's the first part of my talk. Genetic pessimism. So now it's 10,000 hours, second part. So a number of studies have been done of musical genius, chess genius, and other types of genius. And a common conclusion is that to become super proficient at anything, you need to have at least 10,000 hours of practice. That's not to say there are no genetic differences. Mozart was famously hothoused by his father, but so was his sister, so was his older sister. And she became a very accomplished musician, even a composer, but didn't achieve the genius of Mozart. Now, maybe there was sexism involved, or maybe there was, in that environment, which was so similar for the two siblings, maybe some genetic differences did manifest themselves. But both of them were exposed to this incredible amount of stimulation of the brain, highly systematic, highly skillful shaping of the brain. Children who, how many of you play a musical instrument in here? Could you put up your hands? Many of you play. Okay. Could I get you to put your hands on the left side of your head here? Okay. Give it a little feel. Okay. Now, you won't be able to feel it, but that part of your brain in there is called the planum temporale, in the left temporal cortex. That will be slightly bigger in those of you who learn a musical instrument than the rest of us who didn't, including myself. And it will be slightly bigger than the equivalent area in the right half of your brain. What's more, on average, if I were to give you a test, a cognitive test, for example, remembering a phone number type number, so remember this and repeat it to yourself, 5, 6, 9, 8, 2, 4, 7, 1. Okay? Those of you with the bigger left planum temporale will remember, on average, longer string of digits than those of us who did not. So the thousands of hours of practice and stimulation and shaping of your brain that you had as a result of this musical training has physically sculpted and changed your brain and altered your cognitive capacities. People who go blind and learn Braille commonly use the right fingertip to read the Braille, and the corresponding area in the left hemisphere of their brain will expand. That area will expand. People who go blind and no longer have input to the visual areas of their brain, these parts of the brain start to respond to touch and hearing. People who go deaf, the hearing areas of their brain start to respond to visual stimuli. Okay, so the brain is exceptionally plastic, and not just when people are very young. It's plastic throughout life, gets unfortunately a little less plastic later in life, but as I'll come to the end of the talk, there are some things to do about that. Going back to social and economic factors, there was a beautiful study by Hart and Risley in the States where they were studied 42 children, intensively recorded all their interactions with parents between the ages of 1 and 3 over a 3-year period. And what they concluded was the main determinant of language proficiency, and remember how important language is in intellectual function, was actually economic factors. And these economic factors seem to have their effect via the nature and quality of the interactions between the children and the parents. The children with the poorest language development, who also tended to be the children in the most deprived households, heard on average 13 million words in that 3-year period. The ones from the best homes in that sample heard on average 45 million words. So that's 13 million brain-shaping experiences versus 45 million brain-shaping experiences. And also the complexity of the language differed. Okay, I'm on to my last bit here on brain capacity. Okay, can I ask you all a question? How many of you would, if you were going to cook something, or you're following a recipe, and you decided you were going to go around to the shop to get the things, how many of you would write a note for yourselves? Yeah, okay, that's good. That's better than the last question. Okay, now, what number of items would you write a note for? How many of you would write it if it was 4 items? Good, okay. 5? Okay, 6? 7? 8? How many would write a note for more than 8 items? Yeah, okay. Be quite common. How many of you would never write a note even for, say, 15 items? 20 items? 25? I'm impressed. Can I just ask you how you remember when you do that?
It depends. I mean, it depends upon what I'm going to cook. I mean, if I look it up on the internet and if I see something, I mean, I wouldn't go if I'm Indian. If I know how to cook Indian food a little bit,
right.
I wouldn't be like totally looking at all the 20.
Okay. Right. Okay. But if it was a Chinese meal and you knew none of the you weren't familiar with cooking, would you write a note doing?
20 items is probably a lot of items.
Yeah.
I mean,
Okay.
in a single dish.
Okay. Right. Right. Okay. We'll get the name of your restaurant later. That sounds good. So, what I'm going to do now, I'm going to wave a magic wand, and if you do this, and if you practice it a few times, you won't ever need to write a note again. Okay? So that's just going to give you that to go away with. Tear up your shopping notes. Don't do it anymore. And this is a method for improving memory, or being able to use your memory better. And I'm using this just as an example of one of many different ways in which you can, if you like, artificially train or improve mental functions. Because the brain is plastic, and the phrase by the great psychologist Donald Hebb, which was a psychologist that influenced physiology more than any other physiologist, cells that fire together wire together. So that when you get cells firing together, you form new connections. That's the basis for mind sculpture, for brain sculpture, for how the brain changes with experience. Now, so this method I'm going to teach you to dispense with shopping lists was actually developed by the Romans. And Cicero, the great Roman orator, he used this method regularly for his enormously long speeches to the Senate, which often lasted 3 hours. And he would do these speeches without notes. And the way he would do it would be using this method. He would break up the speech into chunks, and he would distribute the speech around the Roman room, this imaginary room he had. And then he would pick them up as he gave the speech. And the basis for this method is in using bits of the brain that many of us, not all of us, many of us don't habitually use very much. We learn probably not to use them in school because schools are very word focused. And this taps a different set of brain systems that some people use but many don't. So, and I'll explain in a moment how it's done, but quite simply, the first thing you have to do, before I give you any shopping list, first thing you have to do is to pick a familiar route or a familiar room. So when I'm thinking about this, I think of the route between my house and the local station, the local DART station. And I have about, say, 10 places on that route. We won't go any higher than 10 now. So I want you to take a couple of minutes to think of a route, or it could be a room you're very familiar with, where there's a number of places in that room you could be putting things down mentally. Okay? Just take a second to do that. Okay. Just a note, you won't be able to do your shopping listing until you've got really familiar and well used to remembering that route. You have to get that memory in the bag first before you then add on the shopping list. But, so now, what you do, when I give you the shopping list, okay, which I'll have to write down, no, I'll remember it. I want you to mentally place each item, visualize each item being placed at each point on this route. So for instance, if I say cornflakes, I visualize an enormous box of cornflakes blocking the front door as I open it, okay? Exaggeration helps store the memory because exaggeration activates a few million extra brain cells, and the more brain cells are activated, the more connections are made that can later lead to the memory being pulled out again. So cornflakes, and now the second item is potatoes. So for instance, I'm visualize myself, the potatoes strewn about the path between the door and the gate. Okay, I'm kind of, and it's quite good if you can add in some other sensory modalities. I'm feeling myself tripping over or kicking the potatoes. Okay, I'm hearing the dull thud of potatoes as I kick them away. So sound and touch. Milk, there's a huge bottle of milk or carton of milk balanced precariously on the gate, just about to fall over. Okay. Eggs, there's a giant egg at the corner. Okay. And then there's salt, and the post box is invisible in a huge mound of salt. Okay. So I won't go on. So if you just yourselves just mentally, when I ask you to remember that shopping list, all you have to do is to go back where you started and start picking up mentally the items. So you open the door, and I can remember, in spite of the fact that I'm dual tasking here, I'm talking and remembering. Yes, I can remember. There's a big box there. I go out and I can remember. I can visualize and feel the potatoes. I can, thank God, I just thought I'd forgotten it there, the milk tottering on top, because I made it a bit extreme, and I got a little bit of emotion in there because the milk might fall. Okay. The enormous egg I can see on the corner. Thank God I made it enormous, I might have forgotten it. And then the salt on the post. Now that's not bad. 5 items, dual tasking is not bad. Normally you remember 1 or 2. So that's my gift to you to take away tonight, is to dispense with shopping lists. Dispense with lists. You can remember numbers in the same way. You can remember your PIN number that way if you want. There's a whole lot of little, if you like, software patches for the brain like that. But you have to, all of these things, remember the 10,000 hours rule. So finally, I'm just going to talk about getting older. Most of you are young. I'm just a little less young. And however, here's my optimistic note to end the evening, or not the evening, my talk. There's an interesting fact about getting older. All you young things think you're much smarter than us old ones, and most of the time you are, except in certain respects. We tend to have better vocabularies than you. I'm hard pushed to think there's 1 or 2 other things, but I won't go into it just now. However, there's a fact about aging, which is, yes, the 17-year-old will outplay, outmemorize, and outspeed all of you 25-year-olds, okay? So there is this apparent slow decline from 17 to, pretty linear decline in most of these raw cognitive functions, which is why Nobel Prizes in mathematics tend to come very young, because you get these Nobel Prizes when the computation power is at its peak, usually in the late 20s or early 30s, with some exceptions. Whereas things like art, Pablo Picasso, Pablo Casal's art and music, these things can go on maturing because they're built on experience and creativity and all sorts of other factors that can mature, like good wine. They're not based on the raw computational capacity. So as we get older, yes, the mean performance level on most tasks for you young things is higher than it is for us older ones. But those of you who know a little bit of statistics, the standard deviation also gets steadily bigger. In other words, the difference between the best and the worst becomes increasingly wider the older you get. And there is a proportion of older people who maintain cognitive abilities that are not that different from their young peers. And it seems to be the case there's at least 7 factors that influence, not entirely cause, but strongly influence the extent to which you are in one of the older categories that maintain your cognitive functions versus in one of the ones who lose your cognitive functions. And the seven secrets, if you like, are, well, you wouldn't be surprised to hear mental stimulation. People over 75 who keep themselves mentally engaged with games, reading, writing, music have much higher maintenance of cognitive abilities than those that don't. Second one is new learning. If you think one of the greatest differences between a 20-year-old and a 50-year-old is the 20-year-old is very likely to be having to learn lots of new things. Whereas if you get to my age, you say, stuff that for a lark, I'll ask my postdoc to learn that hard programming language or to program that task or to learn that difficult technique. So, as you get older, you get fat and lazy and comfortable, and you don't force yourself to learn new things. So our brain is not getting stimulated the same way as it is when you're younger. So part of the difference between old and young, part of it is disuse, laziness. Second thing is and I just have to say about new learning, it was demonstrated about 10 years ago, new learning generates new brain cells in the critical memory centers of the brain, in the dentate gyrus. This was a total revolution because it had been assumed after you're about 4, you've got a fixed number of brain cells and it's all downhill, you're losing them from then on. Not true. New brain cells can be generated, and that generation is influenced by new learning and by stimulation. Diet, the burgers and the fatty things tend to make you stupid, and the kind of boring salads and fresh fruits and fish make you clever, and that's increasingly true as you get older. Physical exercise, people over 60 who take aerobic exercise, that is exercise that raises the pulse a bit, show actual physical growth of the frontal lobes of the brain and corresponding improvements in mental capacities. And that's younger people like you lot, if you go on an exercise bike for an hour or so and measure your memory afterwards, Shane O'Mara, Trinity College, has shown you get a boost in memory capacity after that. Why? Because exercise stimulates the production of something called BDNF, brain-derived neurotrophic factor, which helps form connections between brains. Stress, severe and prolonged stress, can impair memory in particular. It can cause some of the connections to shrink back in the hippocampus of the brain, the memory center. Thinking young, people who think of themselves as young, that self-perception, incredibly powerful effect on how they behave, and it seems to affect cognitive function as well. And finally, social connection. Older people, there's a linear relationship between the number of neurofibrillary tangles in their brains and the number of social contacts. Okay, that was published in The Lancet a couple of years ago. Neurofibrillary tangles are a strong index of pathology, and that is correlated highly with number of social contact. So I'm going to finish there. Thank you very much indeed.